Welcome to our 5-part series of video tutorials where we will cover how to conduct pilot studies using tangential flow ceramic membranes for the purpose of gathering data for sizing industrial scale systems. In this first episode, we will talk about the concept of yield or recovery rate. In this example, we will consider a clarification application where the component of interest flows through the membrane along with the solvent. The first important factor that impacts the yield is the volumetric concentration factor, also called VCF. When feed is pumped across the membrane system, the volume is split into two fractions. The permeate, which is the clarified fraction that permeates through the membrane, and the retentate, which is the fraction that does not permeate through the membrane and is instead retained on the same side of the membrane as the feed. Particles, such as suspended solids or biomass, are concentrated in the retentate as they are unable to permeate through the porous membrane matrix. It is important to note that in reality, the membrane is not in contact with the feed, but in contact with the retentate on one side and the permeate on the other side. To achieve a VCF of 10, the retentate volume must be divided by 10 compared to the feed volume. This means that 9 volumes must pass through the permeate while 1 volume stays in the retentate, resulting in a yield of 90%. During filtration, the concentration of suspended solids or biomass in the retentate increases as a function of time. The result is an increase in viscosity and therefore a decrease in the permeation flux, also known as productivity. It is important to properly monitor flux value versus VCF and to increase the concentration until the targeted yield is reached. Before starting your pilot trials, make sure that you have enough feed for all your tests. Each pilot unit will have a minimum feed volume requirement. This volume, known as the holding volume, will be your minimum volume of retentate. Depending on your yield target, simple math will tell you how much feed you need for one run. For a yield of 90%, 10 times the minimum volume of retentate is required for the feed. For a yield of 99%, you need a feed volume equal to 100 times the holding volume. The holding volume can also be used to estimate the filtration time for each run, which is useful to know for proper scheduling of tests. How to determine your maximum yield or VCF? This is highly dependent on your application, especially the viscosity of your product and the amount of suspended matter. The maximum VCF you can reach also depends on the membrane geometry. The bigger the channels, the more you can concentrate. The trade-off is a less compact system, resulting in an increased footprint and subsequently higher operating and capital costs. For large-scale systems, it is good to know the maximum yield for the different geometries, as several skids will be working in series. The last factor is the flow rate drop. We typically stop filtration when the permeate flux drops down to 50 to 20 liters per hour per square meter, depending on the application. Be careful not to block the channels with too high of a load of suspended solids in the retentate. Finally, let's see how one can increase the yield. When maximum concentration is reached, the yield can be further improved using diafiltration. If we dilute 1 volume of retentate with 1 volume of solvent, we can further concentrate the added volume and therefore recover 50% of the product that was left in the retentate. This operation can be repeated as many times as required to reach the target yield. But it comes with some costs: higher filtration surface area requirements, and the dilution of the permeate, often resulting in extra evaporation costs downstream. For more details about how to run a pilot trial or to discuss integration challenges and different design possibilities, please contact our Novacep filtration specialists.